Okay, integrations using trigonometric substitution. There are two standard integrals that are used here. This one, which is the integral of something of the form of 1 over root a squared minus x squared, where a is a constant. And this one, which is so we can integrate something of the form of the square root of a squared minus x squared. Now, there is a question in the textbook, and in the old textbook, put it in the notes, the old textbook, it's here, it's this one, and that's on page 451, and in the new textbook, it's outlined on page 473. But it's set out here anyway if you want to have a look at it, which shows why this substitution works. If I let x equal a sine theta and differentiate it to get dx by d theta equals a cos theta, and then rearrange dx equals a cos theta d theta, it's a substitution, very like algebraic substitution. We can rewrite this integral, 1 over root a squared minus x squared, as this underneath, and then we can use, and this is why it works, we can use a trigonometric identity to rewrite this. And then if you follow the rest of it through, you can see that the integral just turns out to be very straightforward. The integral of 1 d theta, which turns out to be theta plus c. So what is theta? Well, x equals a sine theta. So x over a equals sine theta, and theta equals sine to the minus 1x over a. And that's where this comes from. And it's not unlikely that you might be asked to show that proof in the exam and how that works. But of course, a lot of the time, we just use these standard integrals. And they will appear in the table of standard integrals in the exam. So if you look at the questions now, I'm not going to go through all three because they're all roughly the same, just using the standard integral. If you look at number 1, here it is, we use a standard integral because this integral looks like the first one we have there. All we've got to do is find out what a is. So first of all, notice in the standard integral, it's a 1 on top. So we bring this 5 outside the integral, and it becomes 5 integral 1 over root 4 is 2 squared minus t squared. So a is 2. And so it turns out to be 5 sine 2 minus 1 t over 2 plus c. Done. So very straightforward to do these integrals using the standard integral. And questions 2 and 3 are very similar, so I'm not going to go through those.